Thank you very much for joining. Today, the individual Ali Lucasen is in New York. At first, I have to announce, already announced via the email, Ham Fair will be held September 2nd and 3rd. Our booth is announced, Kusaka-san, Roto, and our booth was fixed. I sent you a scan copy of this map. We have a booth, very small booth as usual. So for the eyeball QSO, so please come and meet together for the eyeball QSO. We cannot sell anything here because it's a basic booth. The booth for business is more expensive. If you would like to know the list of club, but it's written in Japanese. And if you need a pamphlet, I have. Venue is Tokyo Big Site, West 3 and 4th floor. Floor is 4th, but this structure is very complex, so maybe announce the display or something there is. Now it's in July, so in August no meeting. In September Ham Fair and monthly meeting. Also third Friday venue is here. I will announce. So nothing in August, September to event Ham Fair and monthly meeting. Today, the Rick kindly show us the update of his homebrew. It's a very nice agenda.
Well, it wasn't like before.
So please,
for everybody who wasn't here in March, I did the beginnings of was a presentation for a homebrew transceiver I'm building. And it was pretty elaborate. You know, I had the OHP and everything else. And I didn't expect, I brought the stuff, but I didn't expect to do a stand-up this time, so there's no screenshots. Basically, it's an update of the rig, and it's presented some problems. Now, as you may or may not remember, basically itself is it's about 20 centimeters, I think, approximately. I think it's 12 high, and I don't quite remember what the depth is. I can't recall where it was last year, but anyway, this is the front. It's a DDS, not a synthesizer, but a DDS type. So it has an optical encoder and a display. And then what I did was I added a sub panel here on the receiver that basically held the LCD stuff, some interface, the controls, and all the wiring. In the back, there's a compartment for the power amplifier here. Well, what happens is there's a chassis that splits. This is the transmit area and the receive area up on top. What happens is you've only got about 8 centimeters here of width. There's approximately 20 here to put the whole receiver module. And there's not enough room. So if you look at the area, I thought, well, this isn't going to work. But if you look in 3 dimensions and look at the cubic area, then there's more possibilities. Because I added some 25 millimeter studs on 4 corners, sub chassis here. So this is the receiver sub chassis. So there's actually the primary chassis, a secondary sub chassis here. Allowed me to build the receiver modules on the sub chassis. And one of the requirements, or my own requirement, was that every circuit would be isolated and fully shielded in its own box, which presents a lot of problems. Number one, making the setting boxes, and number two, interconnecting them with coax, because you're not going to be putting BNCs here. It has to be SMA. I've got the a couple of drawings here I'll pass around. Basically, this is the overall block diagram, and the boxes that are gray are ones that I've already completed. I mean, so they already work. The other ones, you'll see that actually there's more white than there is gray, are yet to be done. And then there's a secondary front end block. It shows how the front end itself is wired, because it has to be bidirectional in some cases. So you can take a look at those, and if there's any questions while you're going around. So we'll get the first module out first. This is the receiver module that sits on this plate. Hard to believe. It sits on 4 studs, 25 millimeters high. So it sits like this in the receiver block area. Actually, it's reverses like this. And there's another module here that's actually mounted on the chassis, which is the audio amplifier and DSP filter, side tone oscillator, etc. So it has to mount in here like this. And unfortunately, there's minimal clearance. Everywhere I turn, I'm working with a millimeter or less clearance. And as you look at this, as I go pass it around, where screws locations and feed through capacitor locations really become difficult, because I made so many mistakes. I put things here and I thought, oh, well, this is great. And then I thought, oh, my gosh, I can't get a screwdriver in there because there was a connector in the way. That happened more than once. So I kind of learned as I went. Before I drill any holes, you put it in there and see what's around it first. As you'll notice, it's full of SMA connectors and cables, and these you have to make up yourself, every one of them. I had never done an SMA connectors before, and I was scared to death of it. I still don't kind of really do that or not. But I bought the crimper, and I got some. Well, most of these are cheap Chinese SMAs, because good SMAs are going to cost you 1,000 yen for each one or more. And considering the number I've got here and there and the machine, it would probably be 60, 70,000 yen just in connectors alone. But you can get them cheaper in China, so that you don't pay very much. The downside is the gold flashing, the plating is much thinner, and they are subject to, well, mechanically they're not made as tight specs, so it's very easy to cross thread a connector. So you have to be very careful that when you insert it, you get it all in its thread, and don't tighten it up because you'll strip it out. So basically you want to snug it, and that's it. And of course, these are not, SMAs are not the Japanese standard specs. So you have to use a US size wrench. In this case, it's 3/16 because these are all BNCs and the larger M-type connectors. Type. There's a Japanese size and there's a US size, a European size. They look the same, but they're not. In fact, if you can buy, I'm sure that, I remember when Hans or somebody did the deal with MFJ antenna thing a year or two ago. If you buy from Akihabara an MFJ antenna analyzer, for example, it will have US style coax connectors on it. And if you buy an M-type Japanese connector, it'll only thread about halfway on. So it's something to think about. SMAs are standard rolled over, so there's no problem. But the wrenches have to be US size. In my case, I have a pile of these things. Teletype. All my tools from my teletype repair era. But this is basically it. What we're looking at here, and I'll show you the physics in place, is the RF stage. This is the mixer, noise blanker, crystal filter, and IF. And from the IF, you go underneath. This is the BFO and the filter. And this is going to be a tight one, is the detector and EGC. And unfortunately, there is a lot of electronics that has to go in here. And I don't know, to be honest, if it's going to fit or not. No, except the boards. The boards are in there, but I haven't built it. There's only a few things. But when I pass this around, everybody remembers Hans. I mean, I didn't realize that Hans has such a reputation in Europe. Do you know, well, I don't think there's a Japanese equivalent, but in the States, the ARRLs, the big thick ARRL handbook. So people write articles, for it, etc. Well, in the UK, they have the same, the RSGB's handbook. Most of the RF section, Hans wrote. I've got a copy of one of the older versions, and there's his name, editor, and boy, he did half of it. So quite amazing. I mean, I didn't realize that outside of the TIARA club, I've got some of the stuff. The reason I'm opening this one is he has a programmable crystal that he sells from QRP Labs. And that was his own personal little hobby endeavor. And I bought one, and it's in here. So I'm going to open this up when I send it around so that you can see it. Now, inside, you will see a little tiny programmable crystal. It's 2 layers, synthesizer on top, and a CPU on the bottom. And there's a BCD switch that you can set output frequencies. And it has 3 outputs. I'm only using 1. And it goes into, in the compartment next door, the filter. And I'm not going to use this particular filter, I'm going to use it in another location, but this is one of the filters from Hans. It's for this whisper stuff. But this is the size of the board. The board has got headers on it, and it will fit in here. And right now, although what you're seeing here looks like hookup wire, it's not. This is actually 50 ohm coax. Honest to goodness coax. And I use it to bypass, but I'll send these two around so you can take a look at what Hans puts out. This is only about 1,500 yen for a one filter. This filter is from 160 all the way up to 10 meters, I think. Pass filters, and this particular one is a bandpass filter. Very reasonable. But I'll leave this off, and you'll notice that, again, the RF is all through connectors. All the signal lines and DC is via feed through capacitors, everything. These are 1,000 picofarad capacitors that are soldered to the inside on the foil side of the board. The boxes themselves are all, I made them all. They're made out of 1 millimeter thick foil board, this, PCB. And these aren't fun to make because you have to cut it, size it, solder it on there, and make sure it's all 90 degrees, straight, everything, there's no holes in it. It becomes very tedious after a while. So, by the way, this output here, coax, is actually audio. It goes to the audio stages below. So, and the holes here, it's not for ventilation. Basically, there's a header connector, and the wiring, some of it's got to go below, some of it's got to go above. So the holes are basically to get the wiring to go where they can go. It's set up, and this was done specifically. Once it's in the receiver, you can't get anything else. I mean, if there's other adjustments or screws, you can't get them. So the point being is, you can take 4 screws out, take this RF in and the oscillator connector off. You can actually bring it up like this, and it opens up the entire receiver area. And if you make jumpers, you can actually operate the receiver standing up like this. So that was the point, that you can remove it, get at the insides, and it's still operational. So, I don't think you'll break it in. Careful you don't catch your hands. You may be surprised. Now, that was the receiver portion. Now I still had the transmitter portion to worry about. Okay, before we do that, maybe we'll send something else around. This is an A4 size of that module actually sitting in the receiver the way it will be. This is the front of the receiver. You can see the S meter and parts of the DDS. I've labeled stuff. So you can see the sub panel, PA area, the rear panel controls, and the way this sits in, it just drops right in. So it actually fills the entire box. I have no room. If I can't get the electronics in those boxes, I'm in serious trouble because I have no more room. Not at all. So the next issue was, well, I got the receiver module made, or sub chassis, and now what do I do about the transmitter? So I was thinking, well, maybe I'll just tack all this in. Just put it on the sub chassis. But then I thought to myself, if I put this on the sub chassis, I have the same problem that I intentionally tried to get away from here, I wouldn't have access. So this had to go on a sub chassis too. But I don't have the room here. So the transmitter sub chassis is actually held off by 5mm studs, hex studs. So it's only 5mm away from this primary chassis, which is good because you can put wires underneath and stuff like that, and still remove it. So here's the second beast. This is why it's 5 kilograms. I just was amazed. This is the transmitter section. These are connectors that go to the chassis, so they're just kind of hanging loose. And what we basically have, the PA is actually what, sitting where? I don't know where it sits. Well, I'm sure that I've got documentation because otherwise I wouldn't know what I was doing. Right. It sits like this. This is the rear. So the PA network, or PA box shielding is here for the power amplifier. And the external coax connector is right here. This is a SWR detector so that it watches the standing waves and the full power. And it's, I don't really care about the SWR per se, but what I'm concerned about is if the SWR were to go high, it could destroy the power amplifiers. So this will be used to monitor the SWR level, which in turn controls the ALC on the transmitter driver. This is the transmitter driver here, and basically, let's see. Yeah. This is a bandpass filter, and it will have the transmit receive antenna relay in it. This is the receiver's attenuator, 20 decibel attenuator. And this is a low pass filter that is after power amplifier, just before it goes into here. There are 2 modules that are actually completed on this one, and that's the attenuator and the SWR detector. I'll take one of those, being very, the SWR detector basically is not a perforated board. It's a solid piece of PCB. And I took a Dremel tool. I don't know what a Dremel tool is in Japanese. A grinder to make islands, so that it's actually it's not etched. It's ground into islands, and it was built that way. One of the other boards would be built the same. This is basically the inside. You'll see it as it goes around. There are a number of different types of SWR detectors, different styles. This is what's called a Stockton, and it uses a pair of toroids. And there's some toroid coil, and there's a 1-turn loop going through the center of the toroid. And I tested this thing, it works pretty good. We'll send this around. This has also got the the signal lines on a connector, so that I can actually take this out also and play with it. Or take the example, and then again, because it's all shielded, if I don't like the way a module is working, or I want to change it, I can just either replace the entire module, same size, or replace the board. If a lot of times for single banded transceivers, you'll see one big huge board. So there's two issues there. One, it's not easy to change. Number two, this radiation signals going here, there, and everywhere. They're hard to control. In this, when it's all shielded like this, you can't get any better shielding. It's going to be as good as it's going to get. So basically, the way the little boxes are made, here we go. Basically, you got a single PCB for the base, and the copper is here. And I cut a second piece that will be the top. I cut it the size I want, and I make sure it's the same width. Then I drill 2 holes through both. So I know, without a doubt, that they will be lined up. Then, now that we have our 2 holes, I have a small, well, in these cases, 6 millimeters, 6 millimeter stud that I screw into, hold it down, same here. Then I solder it. I soldered the stud to the board. Then I remove the screws. So now we have a stud that's perfectly aligned with the holes in the top. Now, I cut a PCB, a little perforated board that will be to where the parts are. It goes here. And then, it's got holes in it also. There is a 7, for the most part, 17 millimeter here. This is a hex stud also. And it has, it's this type with the threads on it. The thread type stud. So it basically screws into here. It does not go through the board, so it screws in someplace up in here. So now I've got the board attached to the bottom, and now I just have to put the top on. I know the top fits because I drilled them together. So there's the screws on top. Once the top's on, then I just simply measure how high it is, and generally they're all the same. Cut the foil board, the boards, and start adding the sides and the top, or the ends on it. And then start tacking them in and soldering them. And that's the way the little boards and the little boxes are made. After about 10 or 12 of them, you get really sick of it. I mean, to be really honest about it. But you also get really good at it. The first time, I tried a hacksaw, and that didn't work. And then I tried 1.6 millimeter PCB board. It's nice and heavy, but it's too thick to score and break. What happens is, invariably, with the thicker boards, when you make a score, say on the top, you want to snap it and then you flip it over and you have to score the bottom. And what happens is you'll miss. And when you break it, it breaks like this, like a little step, invariably. With the 1 millimeter boards, when you score, you can actually see the score when you flip it over. And I use a micrometer type measure to make sure that my rulers is perfectly dead on when I do the score. But you get pretty good after a while. And as I mentioned, with the, wherever they went, SMA connectors, I was really gun shy of doing this, but once you do 2 or 3 and you see how to measure it and how it's done, you can actually do them very quickly and pretty much 100% success rate. In fact, I can make one of these things in less than 2 minutes, an SMA connector. And I can't do that with a BNC. BNC drives me up a wall. I have to bend the shielding back and it never fits. And I get the washer and the rubber thing on the wrong side and all kinds of strange stuff. But these are actually easier to make than BNCs. And surprised.
Blue covers, is that heat shrink?
That's heat shrink. Basically, you don't really need it because there's a ferrule in there, a sleeve that you crimp. It's nice just to cover it, and it I don't know why, but if you buy the cable, there's always got their on it, so I put it on too.
Looks good.
But yeah, the interesting thing is, portion, it's all black, but I ran out of black, so the transmit portion is blue. And unfortunately, the next piece that I've got is red, and then I think I'll pass on that one. But yeah, they're not too much fun. Let's see. Okay, now this next photo is this transmit board on the bottom of the rig, so that we're actually, top of the rig is down, and this is in place. And you'll notice that there's some SMA connectors kind of pre-hanging there. Those are actually, there's 3 barrel type SMAs that go into the receive bay. And it brings RF for the receiver, and it also takes the EDS output voltage that drives the transmitter, and also the PA output comes back. So, as before, each module has got its RF connectors and feed-throughs. The transmit bay and the receive bay on this side and the power bay also are separated with, these are 1500 picofarad type threaded feed-throughs for chassis types. There's feed-throughs that go through all the major blocks up to the front panel power section. So everything is bypassed. Now, in this photo here, you'll see some headers that are standing open right now. This photo was taken a few weeks ago. And since that time, I've got the cable harnesses already built. There's harnessing here. All the wiring is done for the entire rig. Unfortunately, you won't be able to see, I don't think, no, you won't, the receive on the other side, but that's all finished too. And again, this is labeled what modules are what modules. And you'll also see up front the front panel wiring harness. The way it's set up, I mean, it's small. So when you start to build it, you always have to think, what happens if I have to change something? What happens if I have to troubleshoot something? Particularly behind the front panel. What do I do? Now that front panel is designed so that all the cables come out. Let's see, if we're looking at the rig like this is the front. All the front panel wiring goes into a single harness, and it goes to the back in one location. There's also a 16-pin connector going into the transmit bay, but that's, you just pull the connector off. The point being is that I can take off 4 screws and of course disconnect my cables, and then basically the front panel itself can be opened up more than 90 degrees, and I can get access to the back without pulling all kinds of unsoldering stuff and destroying everything. Now, the back is basically designed the same way. I don't know if that other drawing shows it. On the rear panel, on this side, all the cabling in one harness, one location. So in the rear, I can take off 4 screws and some BNCs or SMAs. Actually, the rear panel 90 degrees to get access to the PA area. Of course, is totally 100% shielded, and I can't even get at the screws unless I open it up. So, but it was intentionally built that way so that, like, I open it up like a book and still get at everything without unsoldering anything. This photo here is basically what? On the left side, bottom to top, and you will see those are in place and some of the interconnecting stuff between them. There's one little tiny box that's still on the rig, which is a rather unique box in itself. It's only about this big with 4 connectors on it. And what it is called a hybrid splitter. And what its job is to, let's see if I've got the schematic. Had it here someplace. Here it is. This is WR. This is splitter. The VFO. You've got to send the signal in 2 places. So we have our EES VFO. We have to go to the transmit area, and we have to go to the receive area. Now, I don't want to use relays all over the place, so I use what's called a hybrid splitter. And it's, well, to make it just super rough, let's say this is a transistor, and we have bifilar coils. These guys here, so they're a pair of one toroid that has bifilar windings on it. This goes to the B plus, and there's a cap, and then there is another bifilar coil toroid. This goes to GX. This goes to the receive, and we have a 100 ohm resistor across it. So basically what that does is take the voltage or take the signal here and split it equally into a 50 ohm load, both ends, 50 ohms, 50 ohms. Now, there are a number of ways of doing a split. You could, for example, learn it into a transistor and take one off the collector and take another end off the emitter and split it that way. No big deal, except they're out of phase. I mean, it'd be 180 degrees out of phase, but that's not a big issue. But I wanted something that had good bandwidth, so I used this. And this is the schematic for it. And by the way, when you build this stuff, you really have to document. I mean, really document everything. So every day when I finish working, I either redo some documentation, update it or whatever. And there's basically two pieces to each one, each schematic. For example, the schematic itself, and then the module. It's kind of rough because the software is kind of limited. So basically it tells me the module, where the connectors are located, what are the input and output lines required, so that I know later not to make some terrible mistakes. This one is quite simple. Some of them are relatively complicated. Now these two, I'll send two guys around here. This is the SWR detector itself. The hybrid splitter, and I made the splitter last weekend, and lo and behold, it actually worked, which really thrilled me no end. DDSs are kind of fiddly to work with, as compared to a synthesizer type of oscillator. Now, of course, we're not even talking about analog type VFOs, but a synthesizer itself, square waves, and its levels are relatively constant, which is great. This is the hard part. So you gotta, if you're gonna use it, I mean, obviously the square wave is extremely rich in harmonics, so if we want to use it, we got to filter. So I'm going to send mine, well, this guy puts out a square wave. This is Hans's oscillator. So the next door neighbor here is a filter, a low pass filter. So I'll put it through a low pass filter, and this is going to be 9 megahertz and filtered. Now a DDS will put out, oh, they're really hard to see theoretically. Let's call it a sine wave, but we put these little guys here. It's a sine wave, more or less, but it has little tiny steps in it. And this is where the digital analog converter is making its changes. So it's actually, it's not a pure sine wave like you would see from a RLC type of oscillator. It's stepped, but for the most part, the steps are very, very small depending upon the quality of the oscillator, the DDS chip. More bits, smaller the steps. But the kind of awkward thing with the DDS is that its output, if you look at the frequency, let's say this is 1, 10, and 100 megahertz, the output goes about like this. It falls. So you could, for example, at 7 megahertz, you may have, let's just for an example, 1 volt RMS. But at 10, 40, 20, 15. Let's say at 15, you only had 150 millivolts RMS. Well, that's kind of makes it real awkward to drive mixers because they want a constant level. So this is something you have to put up with and deal with if you're going to use this type of an oscillator. The other, well, good or bad thing, if you're looking at a what is it, FFT output, in DDSs, there is very little phase noise around the primary frequency. There are some strange, spurious signals that are away from the primary one, but again, strange as these beasts are, the higher you go in frequency, the closer these guys get to you. They go like this, they move closer to the primary frequency. But phase noise is pretty minimal. Synthesizers, on the other hand, don't have this issue, but they have phase noise, which Japanese specifications are not too happy about. Because basically, spec-wise, we're looking at, from a harmonic content, second, third, fourth, etc., we're looking at 60 decibel reduction in harmonics out to the 10th harmonic is the Japanese spec. So it's pretty tough. I only hope that I can get close. I had debated whether I would submit this or not. I'll look at my scope. If it looks good, I'll submit it. If it looks dirty, I just go in the air. The whole thing is this thing monster, 40 meters, CW only. That's it. And as I explained in the previous presentation, it was recommended to me for a first rig to one band, because multi-band just brings enormous problems that you may not be capable of dealing with. Keep the power quite reasonable. You get above 20, 30 watts, the PAs become very, very tricky. If they got harmonics in them or other weird things happen, you can burn up boards very, very quickly. So best to keep it low power initially. And if you want more power, you put an amp on the end of it. So now I'm gonna, this guy here, like I said, this one's gonna be trouble. And you're free to offer an opinion if you think it could be done or not done. I'm open to suggestions. Inside this particular module, it's split left and right. And one side is the detector, product detector, and on the other side, the AGC. Now, I'm using a rather complicated AGC. Uses both the IF signal and the AF signal to control the rise time and the fall time. In other words, the attack time and the decay time. So basically the IF is controlling the attack time, leading edge, and the AF is controlling the decay time or the falling edge. And that's as much room as I got. Detector, AGC. Now I'm going to send the circuit around for both. It actually requires 2 pages. This is, again, is the module outline showing me what has to be connected where. The second drawing is the product detector, and this is the AGC. And as you'll see, there are a lot of parts, and I'm only hoping that they will fit. I counted the number of parts and the number of holes, and I've got more holes than I got parts, so theoretically, it should fit. But it never works that way. I've built another board. It's pretty compact also. It's the side tone oscillator, etc. This is the bad one. That AGC there, that's going to be sticky. That has to go. That has to go in there. Everything. Yeah. Do you think it fit? There's one negative there. Okay. We'll see what the results are. But again, putting a lot of parts on a little board, you've got to have some experiences. I mean, myself, 40 years ago, I used to work in what's called a stauke, Japanese word. What's stauke in English? You have no idea? Stauke. Subcontractor, that's the word. I forgot the English. Subcontractor. And it was a subcontractor, a little tiny company, 20 people in Kaneoken. And we used to make test equipment for NEC, Panasonic, but it was all a single order, one piece of equipment. So all the boards were by hand using this type of board, everything. So many years ago, I learned how to pack lots on a small board. It's been many years since I've done it, but what I have found was, and I use this is my pegboard. You can't start adding parts and soldering and then about halfway through the schematic run out of board because you can't go backwards. So the easiest thing to do is get your parts ready and start test layouts. And that's why the long legs, so that the parts can actually go in and the legs can hang. So I try layouts, various layouts, keep packing it tighter and tighter and tighter until it will fit in a given amount of space. So it would be, AGC will have to go in something like that.
Do you say a breadboard?
Well, yes and no. I mean, a breadboard basically is making the circuit first, and it could be this type of board. It could be what they call dead bug style, just soldering, and it's huge. And to see if the circuit will actually work, this is breadboarding to me. Basically what I'm doing here is trying to find the optimal configuration for the parts. The circuit I know works. There's no doubt about it because there's already 2 transceivers that use it. So there's no problem there. The problem is getting the parts on here. And the reason I use this board is once I position the parts, I said, well, that's going to be good. Now, if I took this board out here, just took it out and used it, when I tried to solder it, I would have to remove all the parts again. And I wouldn't know where everything was. In this case, I can leave the parts on the board in their optimal position and then basically transfer part by part to the actual board and start soldering it in. This is interesting. I haven't even soldered this guy, little shield. So again, it just, once I find the position, then I go one by one and move the parts to the actual board and solder it.
Prototyping.
It's positional prototyping, maybe position prototyping, yeah. That's basically what I do. And it took me a while. It's a simple idea, but you never think about it until, oh yeah, I should do that. And what I also do is, once this is finished, I take pictures of it, and I mark on the picture where some of the ground bus or the power bus is going to be, so that it will fit on there. I also, I think, I'm pretty sure, you see black markers everywhere because they mark where it go, how it goes back together again. So what's the opinion? It'll fit or not fit? Yeah, I thought so. I thought so. Well, I knew it was going to be tight, but I really don't have much choice.
Maybe you could substitute it with like SMD parts, and you could work like both parts of your.
Well, yes and no. I mean, if I was going to do SMD, I would do it 100%. And to do it would mean I'd have to etch boards. Now, my wife's not too happy about etching compound or etching material going down the sink. And also it smells bad. I mean,
It's somewhere and sent to you, maybe.
yeah, but I've already spent a lot of money on it. I could actually, the money I spent so far on this rig, I could have bought 7,300 plus a tuner and a power supply, and spent that much. And it's because it's a hobby, you know, so I enjoy it. And I think hopefully if it works, I'm going to super enjoy it. I mean, I wanted to build a rig for the past almost 50 years. And I've started 2 or 3, but never completed one. And this is the furthest along that I've gotten. And I figured I'm 74 now, so it's going to race between me and a box and the rig working. So I don't have any more time to fool around. 30, 40 years ago, I said, I'll do it when I get older. But I just can't use that excuse anymore because I'm running out of time. So, what's that? Yeah, well, I fully intend to, at least if the conditions get better, I can work somebody, but you never know, you know. I could walk in front of a bus tomorrow, considering how clumsy I'm getting.
Are you keeping a build log of how much time you've invested in this, let alone the cost?
No, actually, I was keeping a log of the cost until it got so high that it was embarrassing, and I thought my wife would find it. So I stopped that. And time-wise, no, it's whenever I get time. I mean, considering I work full-time still, doing software work, and I've got to keep time logs for that because the company's in the UK. So I am basically up to my ears in keeping logs and writing daily reports and everything else. So I'm not, this is just whenever it's free time. But interestingly enough, not even 30 years ago, 20 some odd years ago, I had a lot of electronic stuff because I was basically in hardware before I got into software. So I had test equipment, I had little plastic drawers full of parts, and actually we're still living in a previous house, and we got ready to move. My wife says, why don't you get rid of that stuff? So I thought, well, you know, I'm in software, I'm actually doing programming. writing products. I thought, yeah, I'm never going to go back to hardware. So I took it out to the dumpster. And they're all bye-bye. They all disappeared. So parts were zero. So now, in building this, I have a zero-sized junk box. A friend of mine in Australia has got 40 years and 2 garages full of junk. And he just goes out there wherever he wants, he digs around until he finds it. So when I buy stuff, I don't buy just 1 or 2 resistors, I'll buy a lot. And as a result, I'm getting a lot of parts that I'll probably never use. I must have 500 or 600 resistors that are of various sizes. Because it's easier to buy them by bulk. For example, well, they come from China, but everything's coming from China. For about 1,500 yen, you can buy in bulk 200 resistors and of various values. There's about 15, 20 per strip for each value. So you've got a large selection for a very cheap price. And I bought a pair of those bags at different things, so I've got a huge number of those. Capacitors, disc capacitors are the same. You go to Akihabara, you pay 10 or 15 yen per disc capacitor. But if you buy them in bulk, you can buy 100 of them for 200 yen. And that's what I did. It's just easier to buy in bulk. So I've got tons of stuff starting to overflow all over the place.
What you gonna do?
Well, my kids don't want it. If I go, my kids don't want it, so I don't know what's going to happen to it. I mean, I've got tools. I don't have any machine shop tools. I don't have a drill press. I don't have shears. I don't have a brake. So all this hardware that you saw in the photographs, that's all done by hand with a file, a hacksaw, and a nibbler. It's all done by hand, much to my wife's dismay. Because the hacksaw's not bad, but the filing drives your whole wall, especially on thin aluminum when they catch the edge wrong. And it sounds like somebody's screeching on a blackboard. But I've got a lot of just hand tools that I inherited from my father and from my grandfather. So I've got a tool chest. It's called a Kennedy tool chest. I mean, it's an old name in toolboxes, multi-drawer. They were used in machine shops. Because basically, although my grandfather was a rancher, my father actually built vacuum tubes for Heinz and Kaufman in California. Now, Heinz and Kaufman was a company that came before iMac. In fact, 2 guys that started iMac actually worked with my father in the Heinz and Kaufman company. And there was a disagreement and they left and they started iMac. But he actually blew the glass, fabricated high-powered tubes. So he has all the tools that went with it, which some of them I don't even know what the hell they are. In my case, when I was in the Navy, although I was trained in cryptographic gear, and I worked in a rather select group of Navy people, spies, I suppose you could call them. When I was stationed in Japan, my last duty station, in the shop was teletype. And to work in the shop, you had to learn the teletype machine, and Model 28 teletypes, hardware, all the perforators, the printers, everything. So I got my Navy toolbox full of tools to repair a teletype, which all these little wrenches, feeder gauges, spring pullers, all kinds of weird stuff. And when I was discharged, I was actually discharged from the Navy here in Japan. At the same time, they were closing the base. It's actually, we're 246 and 16 in Chuo-Rinken. Chuo-Rinken.
Yes.
16で16%. It's right close to it. There's a base there called Kamasea.
Yes.
Kamasea used to be Japanese Navy construction site for torpedoes. So everything for building torpedoes during the war was underground. So the US Navy, when they came in, they took it, used it for radio direction finding, RDF. So there was a big, what they call an elephant cage antenna that used to be there. And I worked there, but they were closing the base down because they were mostly deactivating those old RDF sites. So the question was, what do we do with these toolboxes? And the officer in command says, well, you're getting out, take the damn thing with you. So I got a second huge toolbox. When I walked out the gate, my uniform, the duffel bag went in the bin, and I had this toolbox that I took with me. And I've still got most of the tools for it. But yeah, it's strange. Now, something else. We're talking a little bit about this kind of stuff and what we do with filters. And there was a presentation here a number of months ago on filters, right? I didn't attend, but I saw some of the video. Somebody did a presentation on low-pass filters. Who was that? Because one of the filters has a very strange name and I can't pronounce it. It's Shesbief or some other weird name.
Shetly.
Is that what?
Maybe.
Maybe. Well, that's about as close as I can get too. I can't spell it. I can't pronounce it. But basically,
Try spell it.
To make it very simple, you can have what's called a 5-order filter. 5-order meaning it's got 5 components. Or we can have a 7-order filter. Capacitor. 1, 2, 3, 4, 5, 6, 7 order. Now, with these filters, the more elements you add, the sharper the roll-off is. So a 5-order is so-so, and maybe a 7-order is better. But unfortunately, if this is the primary frequency and this is the second harmonic, in most cases, with this type of filter, 5-order, you're going to be lucky to get about 25 decibels of suppression. With a 7-order filter, it's going to be close to maybe 50 decibels. Now, the problem is, the present Japanese specs are 60 decibels. So, but it's not as bad as it seems, because if you were to put these kind of results that you may see would be if you were putting a square wave into it, it is extremely rich in harmonics. The harmonic content is very high. If you were to put in a so-so sine wave, the second harmonic, third harmonic are naturally going to be lower anyway. So this will actually be better than it appears on a mathematical calculation. But there is another type of filter, actually, these are quite common, and in fact, this particular one, the 7-order filter, Hans sells it, and that little tiny board I had, yeah, that guy, he actually sells a 7-order low-pass filter on the same size board. There's 3 toroids, super tiny, which unfortunately presented problems for Hans when the ARRL tested his whisper unit. They found that it had harmonic content was too high. Must have been 30, 35 different experiments. I mean, very persistent man. Again and again and again, trying different changes to see if he could reduce the harmonic content. Normally, these little tiny boards fit in a motherboard. So there's maybe 6 filters on the motherboard with relays. And what he found was that these headers, these pins, and the sockets, and the motherboard trace length was causing the problem, not the board itself. It was the way it was mounted, but he was stuck because it had to be little tiny boards for his little whisper module that he was selling. So anyway, same size. Popular filter in the past couple of years that was developed by a man called Tone or Ton, depending upon how you want to pronounce it. Let's see if I can get this right. One here, here, one here. This is a ton type filter, and what it does is it's actually, it looks like a 5-order filter with these extra capacitors. And what happens is capacitors are resonant circuits for the 2nd and 3rd harmonic. So what you wind up with is a curve that looks like this. And this is the primary frequency. This is the 2nd harmonic, and this is the 3rd. And these, for the most part, mathematically, they go 70 decibels or better. Practically, it's a different story. The minor problem here is 4th, 5th, and 6th harmonics, a little so-so. But for this filter, I am going to use the TONE ton filter, and I'll pass this around. And this is actually software that I have that you just put in what you want, and it calculates the numbers. So you will see the primary frequency. This is for 9 megahertz, and where the 18 and the 27 are for the harmonic rejection. The unfortunate thing is about these filters is that as compared to the other version, the L values are quite small. I mean, they're sub-microhenry. They're into the nanohenry ranges. So like on the filters that I'm going to be building, 560 nanohenries and 400 and some odd nanohenries, less than 1 microhenry. At those values, the length of even 2 centimeters of wire or inductance off. Now, if the inductance, because these are traps for here and for here, if the inductance changes, then the frequency is going to shift. You know, it could go this way, it could go this way, or just get worse generally. So they're rather hard to adjust. And I've never done it, so we're going to see how it works. It's going to be interesting. But the good thing about this with toroids is that if you, normally when you wind a toroid, you want to leave some free space here. So I think it's about 30 degrees you want to leave open. So your toroid windings are going around. And the nice thing is that you can squeeze the windings closer together or pull them further apart, and you can actually get a plus or minus 5% change in the value. So you've got a little bit of room to play with. The problem obviously is how on earth do you see a minus 70 decibels what the signal looks like? I have no idea. Just try it and see what happens. So, what's the verdict on fitting it in here? Is it going to fit or not? Getting a big zero in a reply. It's going to be tight. The other question mark, obviously, I guess the block diagram, all the block is here. There's actually, the noise blanker is undecided at this point in time. The box is decided. That's the noise blanker. What goes in or how if it'll fit, I have no idea. The noise blankers are rather nasty pieces of work. They get kind of like black magic, because you got to take the signal, expand it, get the pulse, but you also have to do some delays so that when it triggers, it catches the pulse in the normal IF train. Now, ICOM has done it, and at least from my point of view, I don't have a lot of experience with other rigs, but they do quite well. My ICOM transceiver, the noise blanker, works exceptionally well. I mean, I can, if it's repetitive noise, I can almost totally knock it out, including that stupid over-the-hill radar garbage. I can go from a plus 20 decibels of noise down to S2 by playing with the width and the depth of the noise blanker. Random noise, obviously, it'll take a couple of S units off of it. But I hope I can get somewhere even close to as good as they've gotten. Because 40 meters at night can be noisy. And actually the bands are quite interesting. I'm sure you know what OTH is, over the hill radar, over the horizon radar.
Yes.
Over the hill, same difference, but well, it's not the woodpecker. I remember the woodpecker, the Russian woodpecker back in the 60s. It's not that. It's damn close, but it's not the woodpecker. But it's the same thing. You've got very rapid, high-frequency pulses that just basically block the band out. And because of the power, they desensitize your AGC. So one way of, if you're not going to use any noise blocker, one way of working with OTH radar noise is turn your AGC off, back off in your RF gain. I mean, well, some of the real old guys, Jim.
Thank you.
I mean, back in the late 50s, early 60s, for equipment.
Not that old.
Okay. That's, Dan's not here either. There's a couple of guys in my other club that I belong to that have had their license longer than I have, but with separate receiver transceiver era, initially there wasn't such a thing as a product detector, and it wasn't even AGC, it was AVC, automatic volume control. But when you turn on the BFO, it would load up the ABC, basically totally blowing away the receiver. So when you operated CW, you always the ABC off and then use the RF gain. That was the way everybody operated. And it's kind of interesting that a lot of people in the past year or so, or 2 years, I've heard it mentioned a couple of times, have become accustomed or are relearning an old trick. Oh my goodness, just turn off the AGC and back off on the RF gain. I mean, it's not a new thing, it's quite old, but you can alleviate a lot of the OTH noise by doing that, because the AGC will just fall on its nose. But what I was going to say is that for some reason, the low end of the bands, whether it be 7, what is it, 18.068, 21, it's really prevalent at the low end. For example, 40 meters up, the 7 megahertz can be completely blown away. And if you get up to about 70, 15, that area, the noise will have gone down quite a bit. Now, historically, from years and years and years ago, DX used to always hang out at the low end of the band. That was the DX bucket. That's why extra classes get that area, but generals don't. The FCC was going to wanted to give you an extra push to get your extra class by denying you the location that DX operated at. Because what, in this case, I think general, it's what, 70 to 25 is your low end if you're going to operate from the States. So you basically in Japan, you're totally outside the CW band altogether. Because up here, you get a lot of data running, and this is Never Neverland. There's nothing much out here at all. But the past 2 years or 3 years anyway, most of the expeditions, they announce their frequencies they'll be operating on pre-expedition, just to keep confusion to a minimum. And on 40, you'll find a lot of them up at 7027. That's where they'd like to operate. Now they will move depending upon how much garbage is there. They can weed it down and below. But what I've seen, and if you look on the DX clusters, look on the DX cluster for say 40 meters in the evening. Now you won't see any Japanese stations putting up any spots, but you'll see the Europeans. But you'll find that most of them are up in this area. And I've noticed also that 2015, I would find a lot of DX down at the low end, but now I'm hearing a lot of it up at 18080 and above. So, and because this is just blown away. And I thought we were the only people that suffered from it here in Japan. But there was a de-expedition out in the South Cook Islands a year or so ago. And interestingly enough, all of a sudden, up on the DX watch, it said QRT, OTH radar. They were running about an S plus 30 or whatever in noise in the middle of the Pacific. So, I mean, China's doing it, Korea's doing it, Australia's doing it, US is doing it, I'm sure. And of course, Russia, they've got some of their weird stuff going on. They've got beacon stations on 40 meters at 7039. But at this area here, for DX, this is kind of awkward because we're right about Well, generally speaking, 20 up to in this area is the CW area for the Japanese wobbling, Japanese CW guys. And they like to hang out in this area together. And then this one in particular is bad because that's a Chinese watering hole. I don't know if you are into QRP at all, but if you buy a QRP rig from Japan that's crystal controlled, it'll be one crystal, it'll be 7025. All of them. That is their starting place. So, I mean, you listen to CW here and it sounds like two guys together. I was music, but so it's a little busy in this area, but it is interesting that due to the noise of this radar stuff, people are starting to move up band significantly as compared to a few years ago. And this is strictly CW. I don't know what phone that's. I have no idea. I'm not a phone operator. I've got a microphone, but I have to get the dust off it. I tried it out when I bought the rig, but when I got my license, CW was a requirement. And because I was still in high school and money was tight, CW rigs were easy to come by, easy to make. And at that point in time, there was just a transition starting between the AM and sideband. And AM was pretty easy because the only thing you needed was a plate transformer, a modulation transformer, and throw it in the amp and try the devil out of it with an AF amp. Modulation transformers were easy to get a hold of because in the late 50s, there was tons and tons of war surplus. I don't know, I'm from California. And you have San Francisco in the center. And across the bay, you have a city called Oakland. Now, Oakland was the Pacific storage terminal for all material going into the Pacific, not only World War II, but the Korean War and the Vietnam War. Everything went out of Oakland, and that's where it was stored. Now, the Vietnam War, unfortunately, I don't know what the surplus story was, but I caught in the late 50s, everything was coming back from Korea. And they bring these boxes back. A lot of it never even went. It was destined to go, but didn't go. Boxes, huge boxes. And they were selling it penny for a pound. And it didn't make any difference whether there was a 4CX 1000 in there, you paid a penny a pound. Of course, it could be, 25 old inner tubes. But my gosh, we used to go through, I don't know if you're familiar with vacuum tubes, 813s, 304 TLs, 4 250s, 400s, big glass tubes, lots of power. We'd buy them by the dozen. And the older friend of mine in high school had a pickup truck, and we used to go to Oakland, and they had big, huge scales. I mean, big scales. You bring the box in, and they'd look at the weight and say, yeah, you have $5.52. And we just take it. Oil-filled capacitors, modulation transformers, plate transformers, just unbelievable. But so AM was easy to do, but in the late or mid 60s, early 60s, starting to transition to sideband. That was a sticky business because sideband was kind of like, Sony's Betamax and VHS. You know, the tape recordings, whether it be a beta format or VHS format. There was a war. Eventually VHS won, beta was booted. Well, sideband at the time was basically the same. Started off with phasing sideband. Sideband was created by working with signals 180 degrees out of phase, which worked really well. It was really nice, clean sideband. Unfortunately, it wouldn't stay there adjusted more than 30 minutes. You were constantly adjusting the phasing. And then crystal filters came out, relatively cheap. So all of a sudden, we left phasing type sideband generators and went to a crystal filter type of sideband generation. We just cut one sideband off. And then, of course, it just boom, went from there. But again, high school kids, no money. Once we got on CW, we just stayed there. And I've been there ever since. And to me, it's just, especially in an apartment, CW just beats the pants off of the phone. Now, I've worked enough, I have worked, you know, a couple of sideband contests from the apartment, and actually won the WPX contest for JA1. I got the certificate for sideband, but it's really an embarrassment because I don't have one for CW. And I've worked about 50 countries on sideband, but it's only during contest time. And invariably, if you look them up, look the stations up on QRZ.com, you'll find they have, you know, 25 elements stacked on 40. I mean, just monstrous towers, and which is great. I used to be very envious, but now go for it because they give my little whip a chance. If those guys weren't there, I wouldn't get any DXQSOs. You know, whip to whip, we're in trouble. So anyway, that's about the status of the rig. 5 kilograms, semi-portable. It's too bad. Yeah, it was, target was 3. It will fit in the rucksack. If I put air pack around it, it will fit. Nothing else, you know, I can't put my glasses in, but the rig will go in. But it's a blast is heavy. So it is what it is. One thing, yeah, a little pull along. You know, the thing basically amounts to is that manufacturers have the option of making their hardware, designing their hardware, drawing up and making a nice drawing, sending it off to the milling shop, and they make it up for them. And they come back with these little tiny parts, and they all fit in little tiny boxes. But homebrew, you don't have the luxury. You take what you get, and you know, toggle switches come big, medium, and small until you can big. So, you know, you don't have a lot of choices when you're doing homebrew. And if you did like I did, pick a box that's a little too small, you're kind of stuck. So, but it's an interesting exercise. I don't get as much time to work on it because working full time, I look at the evenings since I have Saturdays and Sundays only. But, so it's been about 1.5 years now. And electronics portion is just starting. There's not a lot of active, as you saw from the diagram, there's not a lot of active components in it. But initially, the last presentation I made, I said that the IF was going to be 8.33 megahertz. And the reason being is because I went to Akihabara and I bought 30 crystals of 8.33. But when I started to measure them, they're all over the place. So I had an opportunity to buy a set of aged crystals from Australia for around 4,000 yen. Now, 4,000 yen for 8 matched crystals is cheap. So the IF is now 9 megahertz, which is a classic single. So basically, I've got 2 active devices in the RF amp, a 1496 mixer, noise blankers, question mark. Crystal filter, there's no active devices, although I may put a buffers and beginning in. IF, there is 1 SMD chip, it's a video amp. And then we get the product detector again, same chip as the mixer. The synthesizer we cheated and used Hans little super duper there. I got from the UK, it's a small chip or block with SMD DSP filled on it. And the power amp. So there's not a lot, and again, the DDS I cheated because I bought it. The other stuff, there's a few transistors in it, but there's not a lot of active devices. So theoretically, it should move right along, depending upon if I can shoehorn it in. Now that's it.
Thank you for the update.
Well, yeah, I can't believe I've talked this long. Are there any questions?
So why did you choose this size limitation? I was wondering.
Well, that's an interesting question. And the thing is that I have an ICOM IC7200 at home that I use for my base station. And it's about that high, this wide. It was the cheapest ICOM rig available. It never sold very well in Japan, but it was very, very popular in the States for camping, not mountain climbing, of course, but camping, because it's built, again, like a battleship. I mean, it's really heavy, very, very tough. And so that's one HF rig, 100 watts, all band, SSB, CW, whatever. And then I have also an ICOM R75 receiver. It's a receiver only. It's a triple conversion rate. I linked it to and run simultaneously. But so I'm going to make a rig. Why would I make something an all band HF 100 watt that duplicates the ICOM that I have? Finished, either I use the homebrew rig or I use the ICOM. And that didn't appeal to me. Now I have some little small QRP rigs that you can throw in a bag and climb Fujisan if you wanted to. So I thought, well, I want something that well made, well shielded, that I can expand upon later, that call it rig, field it, throw in a car and take it operate portable. Of course, that's getting marginal now. So that was the reason for the decision to go with a single band, etc. And a portable rig, I couldn't see it being bigger than the one I got at home, so I wanted it smaller. And Akihabara does not have a lot of size choices. Teeny boxes, or you can buy some very, very elaborate stereotype cases for 20,000, 30,000 yen. Or you can buy the box that I did, and it's 20 by 12 by about 22 maybe, which was, I thought, a reasonable size until I started building it, and all of a sudden, oh my goodness, I just totally ran out of room. I mean, if I had opted for that box size and just bought one big monolithic board and put everything on a single board, it would fit. I could make it a lot smaller. It would probably be a bird chirper. I mean, I would probably have spurious emissions all over the place, and it would, in the end, it'd be a waste of time. I would have spent half a year building it, a lot of money, and in the end, I'd have probably just shit-canned it, to be honest. Something like this, I know is gonna work. I know I'm not gonna have any problems with spurious emissions between modules. The only question mark is the final emission, the output harmonic content and noise content. Will it meet the Japanese specifications? Theoretically, mathematically, yes. But you never know what kind of gremlin will sneak in. Can't bring the whole rig anymore. It's kind of a shame because the front panel was an exercise in itself. The front panel is, when you make homebrew stuff, people always have trouble putting labels on. You know, you spray paint it and then you put decals on, or you try and put magic marker on or something else. And I certainly didn't want that for this. So this particular one, the front panel was made with software for the dials and all the labeling. I printed it out on photo print paper. Then I took it to English, what's English? Stationery store. Yeah, I have trouble with English sometimes. Stationery store, and they laminated. So actually, because of the size, I can get a pair of panels in one A4 size. The panel's only about this big. So it's laminated, then punched it, and then stuck it to the front. And it turned out quite well. And the LCD, I don't really know if you're familiar with the Elecraft K3 or K2, K3, both same. What they've done and is it's pretty fancy actually. They've got their display, and then on top of that, they have a plexiglass cover. And they have screws here. And it's the main knob. So the plexiglass actually just screws right to the surface of the front panel. It's nothing super fancy like you see with the ICOMs, it's the Assoc. And initially, I did the same. I know not the same. I had the LCD mounted, and then I started to see a lot of fingerprints and garbage accumulating on the display. Oh, this is bad. I'm going to scratch this thing. So I got some clear plastic that was about 3 millimeters, maybe thick, and I cut it, polished it, drilled it, so that it now sits in front of the LCD. And then I used, instead of normal screws, I have a hex type screws, black hex heads that are here, here, and here. So that adds a little character. And then right underneath, 6 push buttons and the actual label for the top underneath the plastic. This is for up and down, split, AB, etc. And the S meter's over here. It's an edge S meter. Power, RF gain, IF gain, AF gain, and then of course this. DSP's up here, DSP tuning, center frequency and width. And then here we've got a toggle switch. And because I ran out of room, it goes up and down.
down here is tune. And then we have noise blanker level. Toggle for AGC on off. And we got a toggle here for AGC. This is IF, this is AF, fast, fast, slow, slow. We separate the IF, fast and slow, so the attack time can be set, hang time can be set, all independently, or you can mix them up depending on how you want to do it. Is CW and CW reverse, and then this receiver attenuator on off, and that's it. And it's all in a little tiny box. S-meter was a pain in the butt because you can't buy S-meters anymore. They're not sold, not made. You can't buy a meter with an S-meter scale on it anymore. The only thing you can buy are VU meters. Now I had an S-meter, an edgewise S-meter cheap, but 3 or 4 years ago, that when I bought it, I'll bet you that there'll come a time when you can't see buying any more S-meters. So I bought it, and I was using it, I think, a field strength meter or something, but anyway. I had to use an edgewise meter because I didn't have the front panel space available to use it around one. The meter itself, the scale, is aluminum, like a thin aluminum that is bent and held in place by a plastic slots. And then the scales on the front, which is okay, but if you want to illuminate the S-meter, it won't shine through the aluminum. So I tried putting LEDs on both sides. And what happens is, I don't know if you know the effect, if you take a plastic sheet and you put a light on the edge, you will see that the light is actually transmitted around the edges. Well, that's what I have here. When I put the LEDs on, the edges here were all bright and shiny, and this was still dark. I couldn't see it. So, that I'm working with, he says, you know, you could make your own scale. No, I don't want to do that, but I did. So, the question is, well, how do you get the scale? Well, on the internet, you can find a lot of S-meter scales, the PNG files or anything else. So, yes, you know, it's one to that, plus 10, etc., plus 40, whatever. So what I did was, I got one of these images off the internet, and then I made an image down here with drawing software and dropped vertical lines to it. Because basically, when you think about it, the edge meter, it's going to have a slight arc to it, but it should travel the same as the arc on a normal S meter. So once I was satisfied that I had the numbers in the S meter and all the colors and stuff along, then I just basically removed this overlay. And it's really tiny. So I printed it up on photo paper, cut it out, put it in the meter, and then once it was in the meter, I found that I drilled a small 3mm hole in the plastic cover and dropped an LED through here, right behind the scale. And it turns out a nice warm orange color that really looks sharp. I mean, really, it looks good. And in fact, one of the drawings, here, this board right here, there's a little pot that controls the illumination, the intensity for the scale here. And this board also has an RS-232 connector on it. Job. It's an RS-232 interface between your PC and the DDS so that I can change some of the programming. The DDS itself is proprietary, but the guy who makes it in Nevada, here in the States, allows you to change some of the parameters for the optical encoder, mechanical encoder, or it's an optical encoder, because the pulse rate is different. Initially, this was a mechanical encoder, but as you may know this someplace, maybe no. That's the back of it. That's an optical encoder. It's this big around, and it's actually made for a CNC machine. So it's a high quality encoder that has 360 revolution. It was a little pricey, but it's sure worth it because the shaft has ball bearing races. It's ball bearing operation. So in fact, it turns too smooth. It will spin. So I did a trick, the same in it. Well, Yaesu Icon uses a very complex braking system. They're higher end transceivers. There's a little kind of a switch thing you can move on the lower right hand of behind the main tuning to increase the tension so that it moves very free or very loose. And it's kind of a complex finger arrangement. But Elecraft and actually Kentec too, did it a different way. It cost probably, I don't know, 2 or 4 yen. The encoder itself, because it's made for a CNC machine, it's got a large lip here. The screws go in here. This is made for, as it is actually a 20 millimeter hole. The shaft is here. So initially, I was going to put the front panel like this, try and recess it, because I thought this was in the way. And no matter how I tried to figure it out, I couldn't come up with some good set of ways of bracing. Okay, I'll cut the 20 millimeter hole in the front panel and mount it right up tight. So that's what I did. So the front panel itself mounts close to, or the encoder mounts right up close. So now you got this 20 millimeter round thing, a little bit of detent here where the shaft goes in. Deal with this. Well, it turns out when you buy a big plastic knob, that if you flip it over, the knob has got a surface of plastic in the hole here for the molding when they make the, make the knob. So I went to the store that sells cloth, 2 millimeter thick felt. And I put a felt pad here. And the knob goes here. So depending upon the position of the knob, you can position it so that it is extremely tight or, and it just spins free. So you can actually set the tension by the position of the knob, which Elecraft does also on their rig. So, I mean, it turns out it's no big secret.
It's coffee.
Huh?
Coffee.
Yeah, it's coffee, but, it's silly. It makes sense. And the reason I found it was because on one of the blogs, there was, these questions, there's different themes, and some guy said, I've got this Elecraft K2, But he said, my knob, he bought it used apparently. He said, my knob is really stiff. And he said, is there any way I can make it any looser? And the answer came back, well, yeah, you get a hex wrench, you loosen your knob, and you move it out until you're satisfied, tighten it, and it'll be just the way it is. And, huh? And the next entry was, well, because they use a felt pad as a brake, the way it operates. I thought, well, that's not too difficult at all. So I tried it, and it just works super.
We better give the room back.
Yeah, right. Gotta pack it up. So,
Thanks again for the update.
yeah, I mean, probably I've been verified to be a little prepared with.
The next meeting will be in Hamburg. So if you like to put some picture or schematic or on the wall of our booth, you can put something on the wall.
There's something very interesting. I don't know.
This is the top view looking down at the receiver section. And this is the bottom view looking up at where the transmitter section will get
I
mounted.
don't know if ham fair to do it, but there's a big ham fair, a big expo in Germany, in Friedrichshafen. Now Friedrichshafen, in the entrance, have what they call a QSL board, a huge board that visitors come in and they put the QSL board cards up on these board. And this year, the ARRL adopted the same idea. So as they go into the ARRL Hamfest area, there was big boards that were full of QSL cards from all over the world. And I would sure love to see Ham Fair do something similar, instead of a stupid information booth to show, all the QSL cards, because I'm sure it would be interesting.